Okay. All right. Good morning, good afternoon, good evening, everyone. You're joining from, as I can see, all over the world. I've seen the registration and your name coming here. You're coming from Australia, India, UK, Ireland, Croatia, Germany, Israel, France, the US, even if it's a bit early, uh, South Africa, and much more. Now I want to travel and see each one of you face to face. But first, please feel free to ask all your questions on the chat. We will answer them at the end. I would like to thank you for your time today. You're working in various verticals: financial services, manufacturing, retail, internet and software services, healthcare and education. But you all have one thing in common. You're all using and accelerating your business thanks to Kubernetes on Microsoft AKS, AWS EKS, and Google GKE. Our mission at Cast is to help you getting more visibility in these environments. The utilization, of course, but also the cost. Optimizing your compute and workloads. So what you're using and what you need for your application is exactly what you're paying. And the third thing, what we want is you can automate your whole Kubernetes experience. So you can focus on your day-to-day mission while keeping your budget optimized. I will be your co-host today. My name is Ferredopno, and I'm leading our EMEA and APAC go-to-market and teams at Cast AI. I've got the honor to be today with Kim, who is our EMEA technical and Kubernetes expert, who will be our main presenter. Do you want to say a word, Kim?
Sure. Hello, thanks for your time and welcome to the Cast AI webinar. We will show you today what Cast AI can deliver in this read-only mode, most of you already using, and what is the real power of Cast AI's automation.
Thank you, Kim. All right, Ivan at OpenX describing perfectly the power of the platform and the importance of information, data, savings, everything you will be able to get from Cast AI. Today, yes, Kim, you and thousands of other Cast AI users are getting the right visibility thanks to our solution. But it's only the first pillar of our proposition. We're helping you analyze in a single and unified view all your Kubernetes, your workloads across all cloud providers, your cost breakdowns. But that's only a third of the value proposition. Kim will show today how our solution will also help you automate, but also optimize constantly your nodes, your workloads, your instance, and instantly execute these changes for you. Finally, our mission is to help you maintain these optimizations while protecting the performance of your application. But I'm speaking about it, and I think our customers are speaking better about it. So let's see what actually Sanjay from Game 24/7 is speaking, how their users have a world-class experience without incurring a very high cost thanks to Cast. DK at Akamai is sharing 40 to 70% cost savings he was able to get from the platform while bringing more bandwidth for its engineers to focus on other areas. Finally, James at Nielsen IQ is highlighting how automation is helping him now and for every new workload, application, and project the company needs to accelerate on. But we've got a great platform, so let's spend some time with Kim looking at it. Kim, do you want to show us a bit more?
I will take it from here. So you should be still able to see the screen, but let me change this.
We can see the screen. We can see the screen right now.
I will, because I want to show you a little bit more as just one website. So here we go. We should see the screen, and you should see the Cast AI console. So a lot of you already using Cast AI for cost visibility. Cast AI visibility is one pillar, but Cast AI is more than just a visibility and recommendation engine. So we are a strong Kubernetes cost optimization platform. What does it mean? So we see my cluster is connected. For everybody who's new to this ecosystem, adding cluster to Cast AI is very easy. First of all, you need an account. Go to cast.ai, make an account for free, and then start adding cluster. Click the button and then select EKS, AKS, or GKE. What is your favorite provider? Copy paste this command, deploy the small read-only agent, and that's all. Your cluster are connected, and Cast AI is getting data from your cluster, user metadata, no sensitive data, and can give you all these insights of these in this read-only mode. What do we see? I click a cluster and I'm directly redirected to the available saving page, because Cast AI would like to address immediately how much money you can save if you optimize your cluster. So for this cluster, it's a Google cluster, Cast AI tell me I'm paying roughly $600 per month. But if Cast AI would manage the system, I'm coming down to just $170. That sounds crazy. Let's see what Cast AI offers me. If I scroll a bit down, I can see the bare minimum, what we can expect from Cast AI. That's the configuration comparison, shows me the blue side, how my system looks like at the moment. I have 6 instances, 24 CPUs, 96 gigabyte of memory, and overall price is roughly $600. And then Cast AI don't give me the detailed information how Cast would right size my cluster if I would use the Cast AI autoscaler, but Cast AI gives me insights. Say, you just need 8 CPUs, 20 gigabyte of memory, and the cost goes down to $170. Because at the moment, I'm providing so much resources in my cluster, but the applications are not requesting them. We are wasting money. So saving money on the infrastructure side, a lot of people think about Spot immediately. Spot is an option for you, for sure. If we want to see if Spot instance could help us, we can simulate this. Toggle it on, see the Spot-friendly workloads. Cast AI is detecting Spot-friendly applications, which means at the end stateless applications, doing some pre-flight checks here. And we see Cast AI detect 7 of my 26 applications are a good fit for Spot. So if I would place these 7 applications on Spot, it free up additional 4%. It's not much, so that means most of my applications are not a good fit for Spot. But at the end, it helps to drop my costs to just $150. Maybe I say, I know my applications are not the best for Spot, but it's just a testing system. I can live with an interruption. I can live with a downtime of a few seconds for my services because it's a test system. I just want to run it as cheap as possible. We can check for all workloads. Cast AI check what a Spot-friendly cluster would cost. And we see here, my cluster cost is just $34. That's crazy. But if we think about production, Spot-friendly is your choice, or just skip Spot, run on demand. Cast AI can realize significant savings with on-demand only. Other ways are using ARM CPUs if your application is built for ARM, and also the cluster schedule. Define time ranges where the system is not needed, like development systems. The developer are located in the same time zone, working Monday till Friday. Nobody's using the system overnight. Nobody's using the system over the weekend. Why should we run the system over the weekend? So Cast AI can shut down the cluster automatically on Friday evening and bring it back Monday morning. So the system is available if your developer needs the system, but we shut it off during the time nobody wants to use it and save money. All of them are features to save money on infrastructure side. But what's with the workload? And there on top, we have this workload rightsizing. Cast AI want to detect waste in our application. What does waste mean? Here we see Cast AI detected I'm wasting 5.1 CPU and roughly 10 gigabyte of memory. What is waste? Waste is I'm defining requests in Kubernetes, but the application is not consuming them. So my use is not available. So at the end, Cast AI tell me I need to right size my requests. So all this information is available in our cost monitoring, cost visibility. You already use it, so we can go here very quickly. So what Cast AI is doing, we are giving you an overview about your compute cost and network cost and the overall efficiency. And you can drill down these costs by namespaces. You can see which namespace generates which cost. You can see which workloads running inside of the namespace. And then if we go workload by workload, you see the efficiency. And here we see the problem requests are defined too high. My application is not consuming what I'm requesting, so I'm wasting money because Kubernetes exclusively blocks these resources. Cast AI is calculating based on the usage pattern what could be a perfect sized request to give the application enough resources to run without this big overhead of unused resources. So these are the two pillars Cast AI would like to save you money, right size the workload and right size the infrastructure. The read-only mode give me the cost visibility, the recommendation, an overview, a dashboard to see how my overall cluster utilization looks like, and the simulation, what Cast AI can save. But we want the automation. We want to do it right now. So for this, we need to enable our cluster to the active mode. You see, there's a small onboarding script generated. I just need to copy paste this to my terminal. Let's run the script in real time. Cast AI will convert the read-only cluster to an active mode. What the system is doing right now, the onboarding script creates the required IAM role in my GKE account. So Cast AI has the permission to spin up virtual machines to join a cluster and remove virtual machines from the cluster. And in the Kubernetes cluster, we're deploying a few more Helm charts, which are needed for Cast AI to do the spot handling, the eviction, the bin packing, and the workload rightsizing. And if this command is done, which should be in the next seconds, we will see that our Cast AI cluster shows us more options to manage our cluster. You see the last Helm charts are deployed right now. And then the plan is, let's use the automation to optimize this cluster. And you can see how easy it will be. Need a faster system. So last step, credentials will send over to Cast AI, and we will see Cast AI is enabled. Cast AI now is checking if all the permissions are great. Cast AI is trying the permissions generated for the GKE cluster and is using these credentials to pull down the additional information which are needed. And in the next seconds, we can start configure the cluster by using the autoscaler.
I love the power of the demo, Kim. We
It's
always
live.
have these kind of things, right? It's happening when we're doing a demo live, which is good.
Exactly. So it's connecting. I'm refreshing my page, and here we see now the cluster isn't connected. Now we see all the menu items. Okay, first of all, we saw we get recommendation for workload and for the infrastructure. For workload, there is a workload autoscaler. This tool is an additional component, needs to be deployed as well. So we will start with this right now. And after these, the workload autoscaler is deployed, it's additional Helm chart running in the cluster. We can see what Cast AI can do in an automated way for our workloads. Because nobody likes recommendations. Recommendation means manual tasks. I don't want to do any manual tasks. So instead of getting a recommendation, I want a system which can right-size requests on the fly. So we see the system is detecting all my workloads. Cast AI is checking which how the right-sizing should looks like. The value is calculated at the moment. So in the next minute, we will see what Cast AI will do there. Our recommendation, if you want to run this in production, if you want to run this in your systems, is let the system run for 1 week, that you capture 1 week data of your usage of the application, including all the spikes, to get valid recommendations out of the system. That's why you see this yellow icon is say, at the moment, there's low confidence in the recommendation because we just collected 1 minute data. But for this, we don't care. We say we want to see it in action. So we can select workloads we would like to hand over to our Cast AI, turn it on, and now Cast AI is responsible for right-sizing these features. What does it mean? I see for my shipping container, at the moment, I have defined roughly 0.1 CPU, but Cast AI said it's too much. Let's right-size the CPU request. The same for memory. Memory looks like the utilization is very close to what I'm requesting. So Cast AI say, we have to increase the memory a little bit, give it more power. So this is really important. Cast AI try to will right-size the requests as an optimal level. If there is a need to scale down, Cast AI will scale it down. If there is a need to scale up, to add more resources because the utilization grows, Cast immediately jumped in and will right-size these requests. And a lot of people think in this moment, okay, how can this work together with my GitOps dependencies? It's like a charm. So how does the system look like? You see it's a deployment. If Cast AI would change a request on a deployment level, your CI/CD solution like Argo or Flux will detect this and will override it immediately. So that's not a good idea. So Cast works in this way. If we want to right-size the deployment, Cast AI trigger the rolling upgrade of the deployment launch a new pod, and during the pod launch, Cast AI is using our mutating emission webhook to inject the right-sized requests on the pod level. The deployments stay with whatever you've defined in your Git, but all the pods coming up with the new right-sized request controlled by Cast AI. That's smart. And for each workload, you can bring in custom configurations. You can define what should be the overhead. You can define when Cast AI should trigger in right sizing. You are 100% in control what's happened. And if you think about how to enable a workload also in a GitOps way, there is no need to go to an UI and click a button. Turn it on, turn it off, and all the tweaks can be done directly as an annotation in your parent object, like a deployment. That easy is workload right sizing with Cast AI. So if we enabled the workloads we would like to right size, Cast AI is removing the waste in our definition, but still we have to right size our infrastructure. It looks like this. There's potential to save a lot of money. So let's do this. So for this, we have the Cast AI infrastructure autoscaler. The Cast AI autoscaler is a replacement for other autoscaling solutions like Kubernetes cluster autoscaler. You have two different sections. The node configuration is managing more infrastructure-related settings. The settings are very different based on the hyperscaler. So we see here there's a GKE cluster. If you check an EKS or AKS cluster, you will see different options, but at the end, it's always the same. What is the network? What is the firewalling security? What is the instance profile ARN? And so on. So if we configure this, we're defining what is the max pod count, stuff like this. Do we want to have a custom image? We're supporting custom images for all three hyperscalers, like custom OS images. And if we check our settings, if we tweak this matching to our needs, we need to bring up our node templates. The node templates like what you know as a node group or node pool from the hyperscalers. So the Cast AI templates always start with the default by Cast AI. So what do we see? It's like a catch-all template. We don't have taints and custom labels here. We want to match with each workloads to make sure workload can be scheduled. We can define to which node configuration our template should be linked and which kind of lifecycle do we want. Is it on demand? Is it spot? Is it both? If we enable both of them, Cast AI is using on demand as a default. It's totally safe. So no risk that workloads will be surprisingly scheduled on spot. You're full in control what's happened. If you just want to have spot instances, disable on demand, and then we see it's an on demand, it's a spot only cluster. But the problem with this is what's happened if the region is running out of spot instances. In this case, no spot instance can be claimed. Cast AI solution is the fallback feature. Enable this, and if the region is not able to give you a spot instance, Cast AI claim an on demand node. We call it fallback node, and make sure that your workload can be scheduled. During the lifetime of the fallback node, Cast AI will observe the region and check if a magic spot instance comes available. If there is one, we will claim it and replace the more expensive fallback node with the cheap spot instance. Other features are the diversity feature, also powerful, reducing the risk that you lose a lot of instances at the same time by interruption. How does it work? You have 10 spot instances, and all spot instances are the same type of instance. If AWS, Google, Azure, whoever kills or interrupts this type of spot instance, you will lose all the 10 machines at the same time. That could be a problem. So for this, the diversity feature can help. You're allowing Cast AI to spend a little bit more money, per default 20%. And what's happened now is if we see an auto-scaling event, Cast is checking what is the cheapest spot instance, costs $10. So Cast AI is allowed to use other spot instances up to $12. And Cast tried to bring in the biggest mix which is possible to make sure that the risk is very low to lose many instances at the same time by an interruption. So we can, I want to use both of them. So on demand should be my default. I want to make it very safe and use spot instances just if I have the right tech in my application. I can define which architectures are allowed. I'm okay with both of them. And then a nice feature, this is just supported on Google. Google gives us a feature called custom instances. And by using this, Cast AI is checking what is the better option, using a standard flavor with a default CPU memory ratio, or should we create a custom flavor? If your application requires something like, I need 1 CPU and 500 gigabyte memory, Google can create a virtual machine which exactly match to your requirement. The autoscaler is aware of this, and the autoscaler all the time is checking what is the best option for you. And here we see how the autoscaler is working. Cast AI is checking which instance types are available in the region. And if Cast AI receives an autoscaling event from Kubernetes, because the Kubernetes scheduler has not the possibility to schedule a pod because no resources are available, there is an autoscaling event created, Cast pick it up and is checking how many resources are requested by the workload, which is pending at the moment. Which instance types could be a fit? What is the best price I can get? And so based on this, it takes a second. Cast AI make a decision which instance type needs to be launched this time, bringing in the right instance at the right time. But maybe you have technical dependencies. You say, I cannot use every or each instance type. You can bring in constraints to guide the autoscaler into direction. Maybe you say, but my application needs storage optimized machines. Okay, tell the autoscaler, please use storage optimized machines. And now we see from 400 something, just 280 available instances. And then we can bring in more. Maybe we also want to avoid max machines. So yeah, maximum CPU count should be 24. So we see only 180 instance types will match our requirement. So the autoscaler is limited to this, limited by the constraints you bring in, cannot select other machines, but bring up these machines you really need. That's the idea of our smart instance selection process. If we've done our configuration, we save our template is saved. If we have more templates, if you have multiple node pools at the moment, you will end up with multiple templates. Add a new template, give it a name, define if you need a taint, define if you need a custom label. You see a short preview how the workload needs to be configured to match with this template. You see there's the node selector, could be also a node affinity. And then always the same story. Define if you want to have we can just do this. I want to create a spot template, give it a taint, give it the custom key so that it's matched with my workload. I want to run spot. I want to have an on-demand fallback, and I'm fine with this. So we see I have two templates, one template which is creating on-demand per default, and one template which is creating spot instances if the workload triggers this by using the node selector. Perfect. We adapted all our templates. Let's turn it on. Let's see it in action. So for this, the autoscaler is very lightweight. First of all, we need the unscheduled pod policy. Gives me a short review how my templates are configured at the moment for the first use. So I need to toggle this menu off. The unscheduled pod policy allows Cast AI to scale out. The node deletion policy is a different way. We want to remove empty nodes from the cluster. What does empty node mean? There's no pod running beside a daemon set. If we detect nodes as empty, the TTL starts to count. Per default, it's 5 minutes. You can set it to whatever you want, hours, minutes, seconds, 0. And if the TTL is over and the machine is still empty, Cast will remove it from the cluster. But getting empty machines is hard in Kubernetes. Kubernetes scheduler is very inefficient in this, and there is no real bin packing logic. So for this, we're shipping our component Evictor. The Evictor is doing ongoing bin packing in the cluster. Evictor is checking how can I move pods from one node to another node to free up nodes, and on the other side, fill up nodes that we have a utilization of best case 100%. The Evictor in this configuration only touched pods part of a replica set of minimum 2 replicas. This gives us the possibility to safely move pods without interrupting the service. If you have single pods and you want to allow Evictor also to touch these pods, you can bring in your custom configuration based on Kubernetes labels, or you say, I'm okay with the aggressive mode. Evictor, please kill these pods. I want to save as much as possible. So we configured our cluster. The policies are active. If we would wait a few minutes, we will see that the node's dropping out, but I don't want to waste so much time. I want it now. And there is a way for I want it now. We call it the rebalancer. The rebalancer is a maintenance task. The rebalancer is a way to force a new cluster layout. We generate a plan. The rebalancer is checking what is the resource request, what is the placement logic of the workload. And here we see, based on our templates, Cast AI see we switch over from these 6 instances. We will replace 5 of them by just 3 instances. We reduce the amount of CPUs, we reduce the amount of memory. Cast AI decided to use the custom instance in Google because it's much cheaper. And we see most part is running on demand and 1 machine is running on spot. The perfect match for our workload. Say, perfect, I like this. I want to execute this. Now the rebalancer in the backend is running, spinning up the right machines, moving over the workload and deleting the old machines fully automatically. And this is the magic of Cast AI. Have a strong automation to optimize your workload, have strong automation to optimize your infrastructure. If your cluster should be optimal, if your build should be optimal, you need to care about both layers. Just an infrastructure autoscaler is not enough if your workload is going crazy. Just optimizing your infrastructure is not enough if your autoscaler wasting time by selecting the wrong machines, wasting money by selecting the wrong machines. That's, in short, what Cast AI can do for you. You should start today by enabling Cast AI and use the strong automation.
Thank you. Thank you so much, Kim. I'm always impressed by the platform that we do have. Always asking to see this during our POVs with our customers. So I hope all of you seen the power, right? The power of our solution, the visibility you can get with our solution, but also, and more importantly, the optimization and the automation you can have on your AKS, EKS, and GK clusters from the compute to the workload level. And you will be able to do this while providing guaranteed performance for your applications. And as a consequence, reduce instantly your cloud bill by an average of 50%. You can see that on the next slide. So that actually your developer teams and your FinOps team can work together. So you want to learn more? You want to do a full POC of our solution? Please book a demo, book a meeting using these QR code. We'll be happy to put this in production, to do a POC on your dev environments and on your production environment, so we can prove you that it's not magic. It is real optimization, automation that will bring you this cost reduction. We look forward to helping you optimize and automate your cloud environments. Thank you very much.